Hello, welcome back. I want to quickly make a video of showing how we can include into a gradient boosting tree code the things like uh, early stopping or shuffling the data and choosing a percentage of the data for training our models, basically which is called subsampling, etc. Which will also include using some evaluation metrics. Let me first define a function RMSLE. So RMSLE is root mean squared logarithmic error loss. We'll see how it is calculated. So we receive true labels and predicted labels. Log true equals to np dot log 1p of np dot clip it at 0. Log pred is so now RMSLE is np dot root mean square. So this function will return the evaluation score, root mean squared logarithmic error. Uh, So basically, the data that we are using in this competition, it was asked to calculate this as the evaluation score, RMSLE. So that's why I'm defining a function to do so, and we'll see how we'll use it in while calculating our validation scores for early stopping. All right, now getting back to the gradient boost trees. So the idea is what we want to do is we want to add early stopping, right? To to add early stopping, we'll need two different kind of data. For training data, x validation equals to none and y. I'm initializing them as none so that we have control over if we want to do the early stopping or not. Hmm. Subsample will be used for selecting a sample up from the data, from the training data. Okay, so once we have calculated ypred here for the train, we'll say if x underscore var is not none and also y underscore val is not none, we will calculate y predicted with y pred val is np dot like underscore val fill value with self dot init value d type equals to np dot float 64, right? One correction is now this won't be Y any longer. This should be Y train, and this also would be Y train. Let's say Y bread. This for Y bread train, right? All right. So now we have Y predicted coming in at both places. First, to do so, we'll also need to initialize a few variables. Best MSC or score rather best score, where scores best model, best score will initialize as np dot float. Validation scores is an empty list. This iteration is none yet. Once we have the okay, so I've made all these corrections. If we have all the trees completed, once a tree is trained and appended to the trees model, we'll again see if x where is not none and y where is is not none. Then we'll calculate update to update where equals to tree dot predict x where, right? Then y underscore pred validated equals to this equals to cell dot planning rate into rate validation. So we are updating y pred val here with the predictions, residual predictions from this particular tree that we fit here. All right, then RMSLD equals to calculate RMSLD y underscore val y underscore spread validate. So you'll calculate the RMSLD for these two. Let's append this into a list that we initialized earlier. Now, once we have this, let's also print the scores iteration I plus 1 RMSLE score 5. Okay, so we are printing at every uh, uh, iteration of the tree that we are building. So now we'll have to see if how does this score compare with our best scores. If well RMSLE is less than best score, best score equals to where RMSLE best iteration is equals to, we need to make an iterations here is equal to I. So we need to update the model here, right? Best model list is nothing but a list of self dot trees. I'll get to it why we are doing so, because in case that early stopping happens. So if this doesn't satisfy, if validation score is bigger than best score, we'll have to see if this has been happening. Validation score has been coming out more than best score for uh, early stopping rounds or not. So this is a number for which, if that many times, if let's say this is 5, so if for 5 times this condition has not triggered, that means that our validation RMSLE is not improving, so we can uh, do trigger early stopping. So else if um, early stopping round is not none and I minus best iteration, I minus best iteration means the difference is greater than equals to early stopping rounds. In that case, we'll just print early stopping triggered at iteration I plus 1, and we just break from there. So every time this keeps updating the best model list. So the last best model list that we have, once we have completed the all the trees build, we'll say if or even if this is none. So basically what we want to do right now is we want to make self dot trees is equal to best model list. Out of these iterations, whatever we find the best models as per the validate RMSLE, we assign it back to self dot trees so that when we are predicting, we don't have to use best model list and we can just go ahead with self dot trees. So I'm thinking if But if this never gets triggered, right? Okay, so we should do this only when if early stopping rounds is not none and underscore where is not none. Yeah, I think so. Now I think this should work. Let's see. Let's see if it is printing the, the results or not. Okay. Oh yeah, we didn't provide the. Okay, so there's a problem with the np.clip. Given interval values outside the interval are clipped on the inter edges max. I think we need to provide a max value here as well. Cool. So we are printing the RMSE scores now, and also we can see that it's decreasing. So see, it's not decreasing much. Let's say that uh, we go for 10 max depth here. It can take a bit longer time, but let's wait and see. Okay, I just let it run for max depth 10, but still it's not increasing as much. Let's say that mm, I make it 0.1. Let's increase the learning rate and see what happens. I just hope that it doesn't start shooting up. Oh, it's going down. Next, 5. So idea is we will there would be few things we'll have to work on. Finding an optimum learning rate to start with, and a number of trees. So basically, generally, what people do is number of trees they take is around 100, 200 range. I'm just taking it very small so that I can. Okay, so now looks like the validation score is started to saturate here. But why did it not trigger early stopping? Okay, maybe let's just print 7 digits after. I just wanted to let it allow it to trigger the early stopping and then show it to you as well. It just keeps decreasing. Oh, cool. So you see here, early stopping got triggered at iteration 23. The moment two iterations got the same validation RMSLE score, it triggered. So now the model that we would have is at that particular point, at this point, whatever the set trees were there in the list of the model, it will have all of those. It will not include this, right? Because we are assigning it best model list again to it. And if and at this 23rd iteration, this condition would have not triggered this condition. Therefore, my best model list would not get updated. So yeah, that's a good thing. It's working fine. I'll just let it, or instead of doing this, alright, so I just let it run another model with 50 estimators, zero point 0.1 learning rate, and 10 max depth. So it was able to reach to the validation RMSLD of 0.078, which is quite a good improvement from where we started. We were reaching till zero point 0.9 or zero point 0.7 of those sort. So yeah, still I'm not using a entire training dataset to train this model due to time limitations. Another thing I want to add in here is use of the subsampling. So what I want to do is basically, mm, yeah, I want to create a sample of X and Y both. We also need Y. So of this length, in this range, I want to create a, hmm, Mm. So yeah, I'm creating indices, a list of indices in this range of this size. So if a subsample size is 1, so it is taking 100% of the x length of x train, converting it into integer, and then generating the that many length vector with integers in this range. Otherwise, if you reduce it to 60%, say zero point 0.6, so it would be taking only 60% samples from the X train. So this is my train, and this is. So we have included the subsampling thing. It will basically be subsampling the rows of the data. All right, now let's say we'll have to add. Let's say we are taking only 50% of the data. I'm just checking quickly if it is running fine or not for a few iterations. I think we can stop the video here. I'll upload all these code of these classes on a repository and share it. But I think, yeah, that's it. So over this, then there can be many more small optimizations on these. Next, we are going to cover the XGBoost tree, which would be a very naive implementation again, because XGBoost is much more complicated in terms of its optimizations, its implementation. So we'll just see a very naive implementation covering basic concepts, which are not including any performance or parallelization optimizations we won't be able to cover. Otherwise, conceptually, we'll cover it and code it, and then yeah, we can move on to other algorithms. That will so XGBoost will basically wrap our series of tree-based methods. Thank you. Bye bye.